Okay, so guys, today I will talk about linked lists in this copy video. I will go to mainly single linked lists and do some coding implementations. So let's get started. So before I start talking about linked list, I need to talk about arrays. Okay, so I talked about arrays during my previous C programming copy videos in the previous two. If you are unfamiliar with arrays, go watch those. A small disclaimer, those are in singular. So if you have a hard time, like if you have difficulties understanding singular, then ask it from someone who might understand. Okay, so in those two videos, I talked a little bit about arrays. And today, I will talk about the array data structure and then we will move on to the linked list. So when we are talking about arrays, there are three things that we need to understand. What I'm talking about here is the array data structure, not the arrays we get from the C programming language. The arrays we get from the C programming language are based on the array data structure. All right. So there are three requirements for the array data structure. One thing is that you can only store data of the same type in an array data structure. So let's create. So arrays in memory are stored as a contiguous block. So what I mean by when I say that is that let's say wait. Okay. Uh, let's create an array. So let's say let's get this one. So arrays are stored like this in memory. Okay. So this is the memory continues to these sides. Okay. So and over here. So this is an array. This is how the array is stored in memory. So right now, 1, 2, 3, 6, 7, so this one has 10 cells. Okay. So here I say it's a contiguous. So the elements are stored in contiguous manner. And what I mean when I say that is that each cell is stored next to each other. So this is memory. So in over here we have some other data that doesn't belong to the array. So it's over here. And give me a moment. Okay. So yeah, as I was saying, so the array only stores data of the same type. So if I want to like store an integer like 8 here, then I won't be able to store a character like h. So this one isn't allowed because you have to store data of the same type. So if I store another integer like 1, 2, 3, and so on, oh, these ones are allowed because they store the same type of data. And the elements, the cells should be next to each other. And the other thing is the size of the array has to be known at the beginning. Like you can't expand or minimize the size of the array during runtime. So when in most programming languages, there are two times we need to be familiar with the compile time and the runtime. Compile time is known as the time the program compiles. Runtime is when the program is being executed. So we can't change the size of the array when this program is being executed. So the arrays have their own advantages. Okay, so I will talk about the advantages and disadvantages of arrays and linked list and other data structures after I've done the algorithm analysis copy. Okay, so because you guys need to be familiar with all the uh, what big connotation and all of those stuff. So for now, let's just say that algorithms have their own advantages. One advantage is that you can access elements in any cell uh, quickly. Like you don't have to go through one cell one by one to access the value over here. You can just say, let's say that this array's name is A. So let's say we have an integer array of size 10 and the values are here. So if I want to access the value over here, all I have to say is A7, I guess. Uh, yeah. So this one, if I want to access the value, all I have to say is A7, and then I can access the value with it. So I don't have to go through all of these. So that's one advantage. Okay, so I will talk about those advantages once I'm done with the algorithm analysis part. So for now, let's just keep in mind arrays have their own advantages. All right. But one disadvantage arrays have is that we have to know the size at the when we are creating an array, and that's actually not practical because we all know that we can't say when we are writing a program, this is the amount of data we will have to use. Like the size will grow. So we can like declare a really large array, but then we will be wasting memory because then we won't be using some of the memory slots. So because of that, we want a data structure that can expand and minimize as the program is being executed. So it reacts to the data storage requirements of the program. So that's where linked lists come in. Okay. So a linked list in linked list data structures, what we have is linked lists are made out of two things. So let's write this properly. So apologies for my handwriting. I'm not the best at this. So in linked list, we have two things. We have nodes and we have something called links. Okay, so a node is a unit where we store the data. So in arrays, we had cells. Okay, so in nodes, we store the data and we also store information about the next node. So this information about the next node acts as the link. Okay, so let's say that there are several nodes like this. So because each node stores the data, so this can be an integer value or a character or whatever you want, float or whatever. Okay, so that the data is stored, and apart from the data, you also store data about the next node. So these can be allocated in memory in various spaces. Okay, so in an array, all of them were next to each other. In a linked list, the nodes can be all over the memory space, but they are connected because we store information about the next node, and this node stores information about this node. So like that, each node is connected. So one particular node may not know where all the other nodes are stored, but one node knows where the next node is. So by that, all the nodes are connected. So uh, you get a linked list like this. Okay, even if you like create a new node, you can add it to here. And this one is quite flexible because if you want like add a new node to any of these positions, all you have to do is you have to restructure the link. You don't have to tamper with the data. The data just exists. And let's say that I want to add a linked list to here, add a node to here. All I have to do is create a node and then change eraser, okay, change where this uh, node was pointing. Is something's wrong today? That's better. Okay, so let's create the node. Change where this node was pointing and then update this node to point to this one. So just like that, I inserted another new node to this linked list. All right. So that's what a linked list is. So a linked list is basically a set of connected nodes that's connected linearly. All right. So be familiar with this concept of nodes and links because most of the data structures that comes after this one are basically nodes that's connected in various ways. So like you can think of a binary tree. Okay. So in the binary tree you have a node and then they are connected like this. So this is a like a very basic binary tree. Okay. So in a linked list, each one is connected linearly like this in a binary tree. So in a binary tree, the nodes are connected in like this. So it's all about the node. It's all about the links. You have the node. In a node, you store the data and data you need about the other nodes that's connected to the node. And by adjusting these links, by connecting these links in various ways, we create various types of complex data structures. Right. So this is the most basic one, linked list. If you understand linked list, then there's a really good chance that you will understand the other data structures quite easily as well. All right. So that's the introduction to linked list. Now let's try to get into some coding implementations. Okay. So yeah, let's get started. Okay. So for coding stuff, okay, for coding these DSA stuff, I highly recommend you guys to use something like Vim or Notepad. That's what you have in Windows, right? Yeah. Yeah, Notepad, because they don't have that auto completion and intelligence and any of those stuff. Because of that, you have there's a really good chance you will memorize what you create. And okay, there you go. So yeah, that's one recommendation I can give you guys. You can use VS Code. There's no problem. But in my opinion, in my experience, Vim and Notepad has helped a lot to memorize this stuff. So in exams, we will obviously have to write this down using pen and paper. So there won't be any auto completion or anything. So it's better like if you run this on your create this on your own. All right. So let's get started. Let's first of all include the header files. We need to include std.h. Then we are also going to need the stdlib.h file. So we are going to dynamically allocate memory. Okay. If you are not familiar with dynamic memory allocation, watch my previous cookies. I talked about them in the second cookie. And 0. Okay. So first of all, let's take a look at the type of functions we need. Okay. So sorry. Uh, First of all, we need a function to create a node. Okay. Then we need to add the node to the head. Okay, add to the head, add node to tail, node at a given position. And then we have so there are mainly three things we can do with the linked list. We can add data to it, we can delete data from it, and we can search data inside it. So these are the three ways you can add data. Then there are three ways you can delete data. So delete from head, delete from tail, delete from a given position. Then traverse. Traverse means you go through the linked list. Alright, you read the content of the linked list. We have the traverse, so we need a function to traverse it. And after traversing, we also have to reverse it. So I will talk about reversing when we uh, try to do that. Okay. So these are like the basic functions we need. So yeah, okay, it's better now. So these are the functions these are the stuff we have to do with the linked list mainly. All right. So yeah, let's get started. First of all, we need to create a blueprint to create a node. All right. So let's create a blueprint using a structure. Struct node. So this one will only hold integer data. If you want to hold different type of data, just change the data, right? And then there should be a pointer which stores data about the next node. Okay. So over here, I created a blueprint. Okay, this one is struct using a structure. So this one is the blueprint. I haven't created a node yet. This one is like the blueprint. We will create a node in this create node function. All right. So if you don't want to repeat this struct keyword over and over, what one thing we can do is that we can use type def. You can say struct node. Okay. So this is one way you can do that. I won't be using it in this group. I will use it in later one. So be familiar with that because it just makes things a lot easier. Like you don't have to repeat the struct keyword over and over and over. All right. So let's create a function prototype. So we need a function to create a node. It's gonna take the data and then create the node. It's gonna return a node pointer. All right. Let's go down. Node create node data. Okay. So what we are going to do is we are going to create a new node. So we will be using malloc to create the node. Okay, so let let's allocate some memory using malloc. That's why I included this std lib.file. Okay, so let's allocate some memory and then let's store the pointer of it in a variable called new node. Okay. Malloc returns a void pointer, and it's always a good idea to cast it in the pointer you want to use. Okay, and then we need to check whether the dynamic memory allocation was successful. So one thing we can use is that we can check whether the pointer is null or not. If it is null, that means there was an issue allocating memory. So what we are going to do is that we are going to let's printf. We are going to give an error okay allocating array to create node. So we give an error message and then we exit the program because we can't use it now. Exit. Okay, so fail. Okay, so if there's an issue, we can exit the program like this. If not, what we're going to do is that we have the new node. Its data going to be the data that was passed to the function, and the next because we just created this node, we don't know where this one's going go where it's going, like to which linked list at one point we are this one's going to get appended. So for now we say the value of next is null, and then we're going to return this new node. Okay, that's how you create a new node. So over here we define the blueprint. Using that blueprint, over here we define the blueprint. Using that blueprint, over here we create a new node. Okay. So once we create a new node, now we need to add it to somewhere. So we can add it to the head, tail, or whatever the position you tell the program to add it. All right. So let's add the node to head. Okay. Let's start with that. to head. Let's call it add to head. All right. And then what I'm going to do is I'm going to pass the data that needs to be added. And then there's another thing. Let's create a pointer. Let's go as head. Okay. So this head pointer will be always pointing to the first element of the linked list. At the moment, because we don't have a linked list, we assign the value null to it. All right. Now let's create one void add to head. Okay. I'm going to pass the data to this one. And then I'm going to create a linked list. So first thing what we need to do is we need to check, first of all, we need to create a node. So let's call it new node and call that create node function. Call the create node function and then we pass the data to it. So this one's going to get executed. Okay, so we pass the data into it and it will allocate some memory and include the data into it. The next variable, next pointer will be null. Okay, so what we did in this function. So now what we need to do is we need to check whether the linked list is empty or not. If the linked list is empty, you know what? Let's not create a global variable. Let's put it inside here. Okay, so one change I'm making is I'm making this head a local variable to the main function. You guys will see in a moment. Okay, so now what I'm going to do is that okay. So I will go through the code. I will write this code and then I'll explain what I'm doing here. Wait. Linked list is empty. So what we're going to do is all right. So let's go to the main function. Before that, close the parentheses. Let's go to the main function and so it should be accurate to head. So I'm going to pass the memory address of head and uh, data. Let's pass 45. Let's compile and see whether do we have any compile time errors. Oh, we have a lot. So what's the issue? Oh, so yeah. So the issue is that over here in every one of the instances, I use the word node instead of I should be using struct node. I'm so much used to use typeless that I uh, completely forgot about it. Okay, over here I should be using struct add to head. Hmm, will I paste that? So it's always a good practice to compile while you're uh, while even if you haven't finished writing the code, because then you can catch some compile time errors. Otherwise, if you have like quite several ones, then it will be really hard to catch when you are when there's when there's a lot. Hopefully that's all. Obviously, got add to head. I finished that. Oh, up there. So, so got one. Oh, the size of in the create header. Oh, here, yeah. A class, and that should be it. No, no, no. Yes, yes, yes. So that's it. Yeah, we're good to go. Okay, so let's go back to the code. Okay, so over here, the head variable is a pointer. Okay, so let's keep that in my mind. That is a pointer of the data type struct node. And when we want to, when we are passing a value to to a function makes a copy of that value and use it inside that function. Because of that, we can't uh, change the value of a variable within another function. So let's say that we have this variable called head inside our main function. We can't change the value. So there are two ways you can pass a variable to a function. Okay, so the first thing is you just pass the variable itself. If so, then the function's going to create a copy of that, and then it's going to use that inside the function. And if you try to update it within another function, it's going to update that copied memory space. So the original value doesn't get updated. So if you want your variable's value to get updated within another function, what you do is that you pass the memory address of that. So I have here, sorry. So I have here this head pointer, and it needs to be updated within this function. Because of that, I pass its memory address, and because it's a pointer, the pointer's memory address data type going to be a double pointer. Okay, that's why there are two stars here, because it's going to be a double pointer. So yeah, so what I'm doing is I'm passing the memory address. So if I call the function here add to head, I'm going to pass the memory address of head and the value I want to add to the linked list. So what I'm doing is I'm passing the memory address, and that's why I use this p over here. So to indicate that it's a pointer, not a value itself. Okay, it's a pointer to a pointer. So what I'm passing is the pointer of the pointer. A lot of pointer words. So uh, after getting the memory address, I dereference it to see whether the value is null or not. If it is null, that means the linked list is empty. That's the only situation where the head can be null. If there's at least one element in the linked list, if there's at least one node in the linked list, head should be pointing to that. All right. Because it's empty, what we do is we don't do any fancy stuff. We just say there's this new node that wants to be part of the linked list. So we update the head to that new node. Okay. So that's what I'm doing here. So hopefully that's clear. And let's say that the linked list is not empty. So let's go here. Let's say uh we have a, oh, that's too big. We have a linked list like this. Okay, so it already has three elements pointing to each other. Not pointing to each other, pointing to the next one. And we have created this new node that needs to be part of this linked list. So that we have this head pointer pointing to the first element of the linked list. So we access this linked list using this head pointer. If we don't have this, then this linked list just exists in memory and we don't have access to it. We access the linked list using this head pointer. So when we are adding a new node, there are two things we need to do. One, we need to add a node to the linked list. Okay, that's linked list. And then we need to update head, because now if I'm adding a new node to the head, that means that new node's going to be uh, the new head. Okay, because it's the first element. Excuse me. Okay. So there are two things we need to do. So there's an order we should be doing that. So for an example, let's say uh, we just updated head first. So I'm going to update head first. So now the head is pointing to this new node. So then what we need to do is that we need to add this new node to the linked list. But there's a small problem. Why? Because now the head is pointing to this new node. There's no way for us to access the linked list. Now it's lost in memory. We don't know how to access it. There's no variable that's pointing to this memory space or to any of this. So if we update the head first, then we are going to lose the linked list. So what we usually do is that uh, we add the node to so right now. So let's go back. Okay. So let's so now head is pointing to this. So the first thing what we are going to do is that we are going to add this new node to the linked list. So this one is we have a pointer pointing to this called new node. We have a pointer. Let's call it new node. This pointer is pointing to this memory space. Using that memory space, using this pointer, we add this new node to the linked list. Then after adding it, we are going to update it. Now we can add a node without an issue. So that's what we should be doing over here. Okay, so if a linked list is empty, all you have to do is you have to update the head. If a linked list is not empty, what we should be doing is we get the new node. Its next value should be pointing to the value of current head. Okay, and then the value of head should be updated to new node. Okay, so it's a very small function. Let's compile and see. Hopefully nothing. Yeah, we good. So that's how you add a new node to the head. All right. So if I like keep calling these functions, okay. Oh, sorry. It's okay. Let's create another one and then let's something like this. Okay. So yeah. Now what happens is that we add these values to the linked list. So we create 45. After that comes 89. After that comes 335. So what we if we execute this, etc. So let's see if we got issues. Then let's execute it. A dot out. Okay. So now we create a linked list and it has these three values. The problem is we don't know whether it got added properly or not. So usually as a practice, what I do is that after creating the add to head function, I usually go for the traverse function because I don't know whether this function worked properly or not. So there's no way to know whether this function worked properly or not because I can't see what's happening. So what I usually do is let's go. I create the traverse function. Let's create the function prototype first. So what I'm in the traverse, what traverse function does is that it goes to each linked list and then prints the value. All right. So let's create a function called traverse. Then we're gonna pass the head. That's all. It's better if I like copy this thing. Uh, Head. We And then we also over here we check if the linked list is empty or not. Okay, it should dereference that. Head p is equal to null. Then what we are going to do is printf linked list is empty. Linked list is empty. Empty. Done. All right. So if the linked list is empty, what we're going to do is we're going to return. We're going to print a value and then stops the function from executing any further because we have nothing to print. If it's not empty, what I'm going to do is that I'm going to create a new variable called struct uh, temp. Okay, so what we're going to do is that we are going to take this temp variable through the linked list and print the value. So let's see how it's going to go. So it's going to first of all start off with the head. Okay, then what we're going to do is that we're going to create a for loop for I can put this inside there as well. Give me a moment. Yeah, let's put it inside here. So hopefully you guys have watched my for loop video before this. Okay, and then the condition should be until temp next isn't equal to null, and then my update statement's going to be temp equals temp next. Right? What I'm going to do is printf. So because this one's going to hold integer values, I'm going to go with d. Gonna go with data. So and then there should be this. Oh, no, no. So it should be like this. Okay. So it's going to print the value, then this arrow, then keep printing the value. Okay, let's give it a go. No, I don't remember this function very well, so regardless of head. Okay, we get need oh, think I'm returning 0 somewhere. In function traverse and then wait traverse out. Yeah, uh, which go down. Oh, I'm returning 0 here. That's the issue. Because this is a void function, I shouldn't be returning anything. So just the return statement is enough. If you're wondering, SLL stands for single linked list. Okay, so there are quite different variants of linked list. So okay, it's partially working. Something's not right. So if you take a look at the execution, what I'm doing is that I adding 45. So after 45 there should be 89, then after 89 there should be 334. So I execute it, I get, oh yeah, the last one, I forgot about that one. So yeah, I will go through the code, then I explain what happens here. Okay, and then what file? Yeah, it's working now. So what I'm doing over here, so let's get it to the side so it's easier. So okay, so we have linked list. Okay, at the moment it has 3 elements. Okay, I draw them quite small, so it's easier to do everything. So at the moment we have three nodes in this linked list. One linked list, 3 nodes. Okay, so I first created the linked list. I should go from the beginning so it's easier. Okay, so this is what happened. So uh, I had this head variable, head pointer. It was pointing to nothing because I didn't have a node. Okay, then I created a node and head started pointing to that new node. So I stored the value 45 in it. Then I created a new node. Okay, so I created a new node and added the value 89 to it and then included into the linked list. After that, head got updated and started pointing towards this one. This is 89 by the way, if you wonder what it is. Then I created another node and then added the value 334. Okay. And then added it to the linked list. And then the head, I updated the head to point to this. All right. So that's how this linked list was created. That's what I'm doing here. So created created a node with the value of 45, then 89, then 334. So in the traverse function, what I'm doing is so this is quite similar to like saying oh int I equals what? Let's say I equals 0, I less than 10, I plus 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 plus, and then you would have some content here, some content, and then equals the column. So it's very similar to what we have over here. So the only difference is the data type is different. So over here we have an integer data type. We have a variable called I, and its data type is an integer. Over here we have a pointer with the data type struct node. Okay, so it's same thing. The value initialized is 0. Over here, the value initialized is the memory address of head. So instead of adding 0, I can add something like 4 as well if I want to. So it's going to start from 4 and go up to until 9 because the condition is less than 10. Okay. So same way, I'm creating a variable called temp. Its data type is this, and it's a pointer. It's a variable. Pointers are a special type of variables. So this one's a variable. It's also a pointer, and the value, the value I initialize with it is the memory address of head. So the memory address of this first node. Then the condition is so the condition is that the temp shouldn't be null. Okay, I will explain that later. And the update statement is going to be so we are in a particular node. In the update statement, what I'm saying, the temp. So what I'm saying is the temp should be the next node. The next node. Okay, right. So right now the temp is pointing to this one. Okay, so what's that? Right now, temp is pointing to this one. In the update statement, I'm saying temp should be equal to its next node. So it's kind of like saying I equals I plus 10. So we all have done this, right? I equals I plus 10. So the I value of I should be previous value of I plus 10. So the same way, the value of temp should be the next node. Okay. So in the last node, it's next is going to be null. Okay, we all know that because we didn't update it. In the last node, the next is going to be null. So we are going to do that. So we are going to start from this node. And then in the update statement, we say after executing the body, the temp should move on to the next one, to the next node. So right now it's pointing to the first one. Then after that, it's pointing to the next one. And then after executing then it executes the body. So it prints the value. Then it starts pointing to this. All right. Then body gets executed. Then it prints the value. Then it uh, points to null. And if it is null, then we are going to exit this loop because null doesn't have this value. So it's going to give us a segmentation fault because we are passing a null pointer. So if once the temp is null, that means that we have reached the end of this linked list. Then what I'm going to do is here. So let's get rid of this follow. I'm going to so I can remove this printf statement and execute again. So what it's going to do is that it's going to give us the same output, but this one feels incomplete because now the 45 is pointing to nowhere. So we need to indicate that the 45 is the last value and the value 45 points to is null. That's why I have this print statement over here. So so as you can see over here, the arrow gets printed after each value. Okay, so there's no way to get rid of that. It's gonna get printed after each value. And once it reaches, I need to indicate that we have reached the end of the linked list. So to because of that, we have that printf null command. So if I get the output, sorry, I got out. Now it's more clear in my opinion. So that's how you actually traverse it. You can't remove that null statement if you don't like it. You have to include that because that's how you indicate that you have come to the end of the linked list. All right. So that's adding to the head and traversing. So we are so far done with two, actually three. We did this one. Let's go like that. And we did this, and we also did the traverse. Okay, so far we are good with three. We finished three functions. All right. Now let's add to tail. Let's create a function prototype. Uh, sorry, it should be here. Void add to tail mode. So now what we are going to do is that we are going to add a value to here. So right now we kept adding values to the head. So now we are going to add a value to the end of the linked list. So there will be a new value over here. Right. So let's go down. Head and then the value. So first of all, we're going to check whether the linked list is empty. If dereference head, should be head p actually. If it's equal null, that means the linked list is empty. What I'm going to do is that I'm just going to update the head. So basically what we did over here. Okay, so basically what we did over here, because we don't we aren't keeping track of a tail pointer. This is enough. Okay, I forgot to create a new node. New. All right, and concentrate. Okay, here we go. Yeah, and then what I'm going to do is I'm going to update the head. Okay, so I don't know, guys. I don't know whether you guys can remember or not, but in Manjusa's lecture, he also had a tail pointer. I'm not going to use that in single linked list because there's only one use case of that. Like you can only use that for one function. There's no for single linked list. There's technically no point of keeping track of a tail pointer, and so did it. So you got so he can demonstrate how to use one. But technically speaking, you don't need one for single linked list. If you when you are doing double linked list, you should keep a tail pointer as well. So in that case, the tails should also be pointing to the new node. Okay. Uh, so yeah, let's see about those when we get there. For now, let's just keep track of the head, and that's all we need. All right. So what I have done here is that if the uh yeah, so if the linked list is empty, we are gonna just update the head, and that's all. So what if the linked list is not empty? So let's go to a new space. Yeah. So let's say we have a linked list like this. So, so we have a linked list like this, and this one points to null, and no need that. Let's remove that. So we have a linked list like this. So what we need to do right now is, well, so the head is over here. What we need is we need uh we create a new linked list, and this one needs to be pointed to this now. So this is the uh existing one. So it's get a different color. Okay, so apologies for my horrible painting skills. I'm not the best at this stuff. Okay, okay, that's how very clear is it? Yeah, let's go back quickly. Let's get some. Oh, that's a bit. That's it. So okay, so the one in green is the is the last node of right now. Okay, so this one isn't linked yet. So the green one. What we need is we need to link the last node into this new node. So for that, we need to go to the last node starting from head because we are only keeping track of head. All right. What we need to do is we need to start from here, and then we need to go and find the last node. The difference between the other nodes and the last node is that the next value of last node is null. Okay, that way we can find the last node. So what I'm going to do over here, okay, so if I go to add to tail, I'm gonna create a for loop. Okay, these ones will look a little bit advanced. Let's see. Okay, so what I'm going to do is I'm going to create a temp variable that will point to the value of head, and then I'm going to go through the and then let's give the update statement as well. Temp goes temp. Okay, and then I'm gonna go through this linked list until temp next is not, so it should be not unequal, it's not equal. So the all right. So all right. So what I'm doing over here is that I'm creating a new variable called temp. It's first it I'm gonna initialize it to the value of head. Then I'm going to keep jumping one node by one node until I reach the last node. The way to recognize the last node is that
its next value is null. So in other nodes, next value isn't null. In the last node, next value, the next value of last node is null. So that way we can recognize it. I have added this part. It's not necessary actually. Give me a moment. Oh shit. There we go. We are adding data, right? Oh yeah, we need that. So yeah. So right now, after this for loop gets executed, so what it did, it started from this one. So this is a for loop without a body. All right. I highly suggest you guys to check my for loop video. It should be uploaded by now. All right. So this is a for loop without a body. So it's quite similar to saying int I equals 0, I less than 1000, I plus plus. So what I have over here, this is similar to this in a way that both of these don't have a body. So what I'm technically doing in this loop is that I'm starting at 0 and I'm going to keep update it until 999 because it's less than 1000. Start from 0, check the condition, update. So it's going to keep updating the value. So right now we don't have use case for this I. We can just say I equals 999 instead of using this method. But we can't use that to this line because we don't know where the last node is. Only the node before the last node knows where the last node is. All right. Because of that, we need to go through each node until we come to the last one. The head doesn't know where the last node is. Only the one that's before the last node knows where the last node is. And we find the last node by this condition that the uh, next value is null. So over here, I have used a semicolon to indicate that it's a function, it's a for loop without a body. Or you can use this syntax as well. Absolutely no problem. Okay, you can, uh, sorry. Instead of this, I can just basically say this. Okay, it's basically the same thing. A for loop without a body. Our only interest is to update the value of temp. You can use a while loop or you can put this inside the body as well. But this is the method where I prefer because it just takes one line and it's easier to understand than most of the other multi-line ones. You just have to get used to it. It's not that hard once you understand it. It it looks hard because we are not familiar with these kind of stuff. So like when you see something new, you're obviously gonna think of it as something that's hard because it's new, not because it's hard, because it's new. So familiarize yourself with this stuff like this, and there won't be a problem. Okay. Once this for loop is executed, now we are at the last node of the current linked list. Now what we need to do is we need to say we need to link this. So what we are going to say? We are going to say uh, the next of this is the new node. So that's what we're going to do. What we're going to do, we're going to say temp next should be new node. And that's it. Hopefully hopefully you guys can understand what I'm saying here. All right. So yeah, that's all. You don't have to update the head because you're not adding from the top. All you have to do is just go through the linked list, find the last one, and update its next value from null to the value of the next new node, memory address of the new node. So let's add some values to tail as well. Let's add 100. Okay, so I should pass the head first.
That's 100, and then add to tail should be head, then something like that. Just random one. And then compile. Let's see. We have a compilation error. Oh, right. Yeah, the issue is over here. So I'm declaring the temp variable inside the for loop. That means that temp variable is only accessible inside the body of the for loop. All right. If I want to access the for loop outside the for loop, what I should be doing is that I should declare the value outside the for loop, and yeah, wait, okay, and then initialize the value inside the for loop, inside these brackets. So that was the issue. So because I previously, because I declared this temp variable, this is the variable. Okay, this is the data. This part is the data type. This is the variable. Because I declared this variable inside the brackets, that meant that I could only use this inside the body of this for loop. And over here, I'm updating the last node outside the for loop. That means I should be able to access the temp variable outside the for loop. Because of that, I declared the variable outside. Now, if I try to compile, I don't get any errors. Okay, let's redirect traverse. I think I forgot to do that. Yes, I did. So let's traverse and try. So you can see whether did they get it added properly. Okay, here we go. So what has happened? Let's go. Here we go. So first of all, we added three values to head. So we added 45. After that, we added 89. After that, we added 334. Then we added 100 uh, to the end. Then we added this one, uh, 4,542. So if I like kept traversing, so I guess you guys can understand. I don't like have to traverse after each entry. Do I? I don't know. Let's give it a try for once. Yeah. Okay, here we go. So added 45 and then added 89 to head. Then added 334 to head. Then I added 100 to tail. Then added 4,542 to tail. Okay. So yeah, that's how you add to tail. So what you guys should be doing is that oh yeah, small thing I need to mention. Don't try to memorize this code because there's no point. There are multiple ways you can write this code. At the moment, I'm not keeping track of tail. Okay, I don't have a variable pointer like this. This one doesn't exist. I don't use that. Okay. In Manjus's questions, he can include something like that. And if so, all you have to do is you won't have to go through all of this for loop trouble. All you would have to do is uh, just something like uh, I would have to okay, so yeah, I would have that new node. All right. So what I have to do is that tail next will be new node. All right. And then sorry, yeah, tail next will be new node, and then I'm going to update the value of give me a moment. And okay. And then what I have to do is that I have to update the tail to be new node. So this is the only use case if you use a tail in a single linked list. Okay, you can only use it for this function, and because of that, I didn't use it because I don't know, I just didn't like it. So what we can do is that we can go through this. So what we are doing is over here is that we are going through the linked list. Instead, if you kept track of a kept track of the tail, you can basically just do it using this two lines. Okay, and another difference is that, as you can see over here, head is a local variable to the main function. I can make it a global variable as well, like this. If so, then I won't have to pass the memory address to each function like this. I won't need this part. Okay, so that's there are multiple ways to write this code. So it's always a good idea to not. It's always good if you don't memorize this code. Don't try to memorize. Just understand what I'm doing over here. That's what I'm doing over here, explaining everything using this whiteboard. All right. So when you're adding something, there's an order how you should add a node to a particular linked list. Or when you're deleting, I will also talk about those when you go through the deleting functions. Right? There is an order, and if you have a hard time imagining how things should work, just take a rough paper and draw something. Draw it, and then try to understand how you should write the code, how you should structure the code. All right. So don't try to memorize this. Understand what's happening, because that's what Mahanju says as well. Try to understand, and that's what he's going to test in the exam as well. Whether did we understand something or not? Like so, if you try to understand something, then you can generalize what you understood to any problem you get. If you memorize something, then you can only apply that to the that particular problem. All right. So a little bit of wisdom there. And moving on. So if we take a look at what we did here, we added to tail as well. Okay. Now what we need to do is add, so we can have the user specify a particular position, and we can add a node to there as well. Okay. So that's what we're going to do next. Before that, let's take a small 5 minute break. Okay. I need to drink some water, otherwise I won't be able to talk. So yeah, let's take a 5 minute break and see you guys in 5 minutes.
Okay. Let me put this on. Yeah, we good. Let's get started, shall we? So, yeah, let's get started. So we did so far we did three things. Okay, we added to head, we added to tail. Now let's add to a given position. Okay, so let's go with void add to position struct node. Right. Let's go down. Okay. So first thing, we should create a node. So let's call create node function, create node, and then pass the value of data. And now let's check whether it's empty or not. Well, basically what we have to do is that we have to repeat what we did over here. So let's just copy it and paste. No need to waste time. Okay, so basically what we did before, we check whether the head is null or not. If it's null, that means the linked list is empty. So we just update the head and need to stop executing the function. Right. Yeah, that's it. So yeah. Now what we need to do is that now the user is giving us a position to include this. So what we need to do is that we need to go through each node and find out what's in we need to find out uh which node the user has specified and then add it there. So let's go to the whiteboard and see what we can do here. So let's say okay, let's say there's a node. So there's a linked list. Okay, like this. Keep happening. Okay, so there's a linked list like this. And the user wants to include a new value at the position 3. Alright. So the position 3 is over here. And if we think of the indexes of this linked list, this one is actually the second index. Right? 0, 1, 2. And we need, so we assume that the position is 0 indexed. That means starting from the 0. So in here we should assume position is 0 indexed. So this is just for my code, all right? Manju sir might give different code. Like he might say, no, the index starts from 1, not from 0. So then this will be this one will be 3 instead of 2. For my code, I'm going to start with 0. Manju sir might say this one starts with 1, or you might even say this one starts with 100. You don't know. That he can say that. If so, then this one's going to be 102. Sorry, 103. Sorry, 102, 100, 101, 102. So in my code, I'm going to say the beginning of the index is 0 index. That means the first index of the first one, 0, 1, and 2. So when we are going to add a value, okay, so what we should be doing is that we should go to we should be in the previous node of that uh, node we want to update. Even when we're deleting, okay, even when we were deleting, sorry, so when we were adding to the tail, what we did was we went to the previous one and then updated its next value. Same thing what we're going to do here. What we're going to do is, so I want to add a new node to this position. Okay, so I'm gonna create a new node like this. All right, and then this one's next value should get updated here, and this one should get updated here, and then this link should get updated to here. So technically, what we're doing is that we are updating the next value of the previous node. So because of that, what we need to do is that we need to go to the previous node, not to the uh, node at the position we want to update. So that's what we're going to do here. So edit position, get it up. Okay, so I'm gonna create a for loop again. Okay, uh, let's create a temp for what I'm going to say. Temp, I can say it over here actually. Temp is equal to the value of at p. All right. Now what I'm going to say is I'm going to create an integer called I, because that's how we keep track of whether we came to the position or not. So over here the position is zero based, zero index. That means it's if because so let's give it some numbers so it's easier to understand. So let's say that the user passed three. So user wants to add a new node to the third position. That means he is going to pass 2 as the value because that's the index he or she wants. That means we need to move temp to the one that's before the second index. That means we need to move the uh, temp to the node at the first index. That means I should be less than plus minus 1. Okay. So it's some it might take a little bit to wrap your head around that. So the user wants to add a value to the third position. So because he wants to add a value to the third position, he passed the index, which is 2. And we aren't interested in the node at the second index. We are interested at the uh, node at the first index, which means the past value, with the past value, the value the user passed minus 1. All right. And over here, I'm going to update I. Over here, I'm going to update Y. Okay. And then within the body, I'm going to keep updating temp. Temp's going to be equal to temp. Uh, Next. Oh shit. Sorry. There we go. So I'm going to keep updating temp until what we find we come to the previous node. Then what we are going to do, okay, there's a small error here. Keep that in your mind. I will address that after going through this update one. Then what we do is that we say temp. We say so. Oh yeah, two things. Okay, let's go through that. So right now, okay, right now, oh, right now. So this is how the linked list looks. Okay, I'm not sure my pointer looks like that. Oh, there you go. So this is how the pointer looks. All right. So sorry, this is how the linked list looks. We need to add this new node into the third position. So two things. We need to update this node's next value and this node's next value. So what if we update uh, this node's next value first? So 1 is done. So the issue is then we lose the rest of the linked list because there's no way to access that. So what we should be doing is that let's go back to where we were. What we should be doing is that we should be updating the new node to the next, and after that we should update this node to this. That way the linked list we can maintain the linked list. So if we go to the port, okay, uh, new node. If you like, if you can't visualize what you're doing, draw it in a paper using a pen or pencil. Next node next is going to be temp next. Okay, why did I use temp next? Because temp is this one at the moment. I'm here, and new nodes next should be. Let's erase this again. Okay, right now it looks like this. So I'm here. I'm in this one. So I'm saying new nodes next is temp next, which is this. And then I'm gonna say temp is temp next. I'm gonna update the value of temp next to new node. Then I'm gonna say temp next is equal to new node. Oh, there you go. So that's what we're going to do. Okay. So yeah, that's how you add a value at position. And before we go on to the next one, I said there's a small error in this for loop. The error is what would happen if the user enters a position that doesn't exist in the linked list. Like let's say that we have a linked list that has 10 nodes and the user wants to include a new node at the position 15. Well, that's not possible. We only have 10 nodes. We don't have a position 15 within our linked list. So in that case, we should throw an error. All right. So what we're going to do is we first of all we need to check that. So what we're going to do is that we until I is less than the one less than the position that was specified by the user, we are going to keep updating. So we are going to keep going through this linked list one by one. And if it reaches the end, if it reaches the end, the temp value is going to be null at one point if the number of if the position is greater than size of the linked list. So we should be checking that here. Okay, or so that we should be checking for two conditions. Temp should be equal to null. Okay, so we are gonna keep executing this until uh we go to the position before previous position. Okay, so that's what we're interested in. Or until temp is null if temp is null, that means there's an error. Uh, so one thing we can say is one thing we can say is that index is out of bounds. Out of, you can use a simpler message printf. You can say given position. Given position is larger than size of list towards, if I'm not mistaken, linked list. And then we can finish executing and close the if statement. All right. So if that's so, we won't be adding this uh, newly created node to the linked list. We just exit, and because we aren't adding it, we aren't going to use it. So we should be freeing. We should free that. Otherwise, there will be memory leak. See, we got any errors? We don't have any errors. So let's say at the moment, let's traverse through the linked list and see what we have. Okay, I don't need all these traverse statements. Okay, so what is it? SL.c. Okay, we got an error. What did I forget? No, from where did I get that? That three should be good to go. Yes. Position is 0 index. Yeah, we good to go. And let's execute the program and see. Let's take a look at the linked list. Okay, let's try to add 500 where 100 is right now. All right. So the position is 4. That means the index should be 3. Okay. And the way I'm doing this is only specific to this code. Okay, you can do it whatever you like. Okay, you can make it 0 based, 1 based, -1 based indexing. You can do whatever you like. Don't just stick to this one. Just experiment a little bit. That way you can learn better, learn faster. Position head. So as I said, index is 3, and I want to add value 500. Let's see whether it works as expected. Uh, what was it? Yeah, error top. Okay, so we have a small error. Given position is larger than the size of linked list. Why did that happen? Let's go down and see. Uh, so that means temp was null. So if position is less than that, oh, how did that happen? Let's keep printing this. Okay, it's okay. So the all right. Yeah, small issue. This should be and not, because both of these need to be true, not just one. Yeah. So let's check this now. Let's get rid of this print statement. Oh, there you go. Yeah, now it's working. So yeah, small issue there. So I had to change this to from or to and. So what we are doing over here is that uh, we go to this one. So we add 500 to here. All right. Hope it's clear. Now, what would happen if we like add a value that doesn't exist? That, like I said before, add position. Let's change this to something like, I don't know, 999. Obviously doesn't exist. So let's, if I compile this now and execute, and the previous one got we this one was added, and then I get this error: given position is larger than size of linked list. If you want to make the error message a little bit clear, you can add the position as well. Given position is, so what I can say is, can say given position is, and then like you can update this whatever way you like. Actually, you can even add the size, because you, if the position is larger, then you probably would have gone through the entire linked list, so you can keep track of the size of the linked list as well. Okay. uh, yes. uh, and then let's create another one. So I did this in the web server page. In case if you don't know, this is known as the compile time concatenation. Over here, I'm passing three separate strings to the printf function, and they will be put together. Okay, you can just try this out in a small hello world program. So just put two words hello and world in two separate strings instead of one. It will be printed as one. Okay, so I can say linked list size, and then another one. For that I can pass I, and in order to use I outside the for loop, I should declare it outside like this. Uh, Oops. There we go. Okay. So let's give it go. Don't have any errors. So yeah, linked list size is 6. So if I like check the linked list size, 1, 2, 3, 4, 5, 6. Yeah. The size of the linked list is 6. I have given the position 999, but the size of the linked list is 6. So what if you take a look at this? Okay, so because I have this new line character, it gets appended to the line. Otherwise, they will uh, all of these strings would be put together. Okay, hopefully I don't have to go through that. You can just do it on your own. It's nothing complex there. All right, so that's adding, and we also did traversing. Okay. Uh, yeah, that's, and after that, what we have to do is that we have to delete, and then we have to reverse. All right. So let's delete now. Okay. So hopefully everything is clear up until this point. If not, then drop me a message and I will see what I can do. So right now we have quite a good amount of code actually. Yeah, 118 lines of code. So let's, yeah, as I said, let's, what was it? Delete. It should be over here. Delete from head. I'm gonna pass just the memory address of head. And let's go here, right? Well, it's another good practice is that because you have a lot of functions, you can have like really long functions, and like in this situation, okay, so let's say that I have a function like this. So right now I don't know which function is closed by this curly bracket. So another thing you can do is, if you have like really long functions and stuff, you can just add the name of the function at the end of the curly bracket that closes that function. So like this. So otherwise you would have to scroll up, scroll to the top, and that will take a lot of time. Sometimes if it's like a really long function, then you would have to keep scrolling up and down. These ones are fine because these are like not even 10 lines long. Some ones, but sometimes you have like functions that's like hundreds and hundreds and lines of long sometimes. So let's add detail as well. And so this add to position one is relatively long. It's like the longest one I have here, I think. Add to position. No, and then traverse. All right. So now what I need to do is that create a function. What was the name of it? Delete from head, right? Yeah. So delete from head, and it's gonna take the memory address of head. So struct. And again, we need to check whether the linked list is empty or not. If it's empty, then there's nothing we can do. Okay. So if it's not empty, what we are going to do is that we are going to, so let's go back to the whiteboard again quickly. So here we are. Yeah. So let's say we have a linked list, 3 elements, 3 nodes, keep happening. Let's go for it's easier. Okay, this one pointed to this one pointed to this one pointed to this. Okay, here we go. So 4 nodes. All right. So I need to delete this. That's what delete from head does. Delete the first node. So what I need to do is that two things. I need to update the head. So right now head is pointed to this. So I need to update head. The other thing is delete the first node. Delete first node. All right. So those are the two things I need to. Hopefully you guys can have an idea what I have written over here. So if I like update the head right now, okay, I can basically say what head is equal to this. Absolutely no problem. Then it, well, technically it does what we need. All right. So if I update the head, so all I have to do is that head is equal head next, head arrow next. So then uh, it would start from that new position. So this one won't be involved uh, in any of the operations we do. But there's a small issue with that. Small issue with this method. It's that we are still using this memory space. We are using this memory space, but we don't use the value that's inside this memory space. So that's not very efficient. So we are wasting memory. So what we need to do is that we need to also free this memory space as well. So we allocated some memory dynamically from malloc function. And once we are done using that, we need to release that back to the operating system so it can allocate that memory to another process that needs some memory. So to do that, uh, what we do is that we create a temp variable, a pointer, and it should be pointing to value of head. And then what we do is that we update the memory address of head. Head, okay, so value of head should be updated to next.
And then what we're going to do is we are going to free the value of temp. So we stored this. Uh, oh, sorry. Okay, where were we? Delete from head, right? Yeah, this is where we are. Okay, okay. So what we do? This one is stored in a. We have a new pointer pointing to this. After pointing, so we update the head. Then we using this temp, we free the we free the node we don't need. And it's always a good idea to set the value of a freed pointer to null. So uh, wait, okay. So yeah, so it's always a good idea to set the pointer value of a freed memory space to null. Otherwise, they will lead to some errors. Over here, we won't have a big problem because we won't be using temp afterwards. But when you're writing a big program, it's always a good idea to set temp to null. That situation is we also call dangling pointers. Okay, when a pointer is pointing to a freed memory space, and if you try to use that when if you use that pointer and try to do something, we will get an error because that memory space doesn't exist anymore. So it's always good idea to set uh, the temp variable to null. So now we delete from head. Let's check it out here. Let's go add to position. So this one's gonna give me an error, and I'm gonna just remove that. It's no need of it. So let's say what was it? Delete from head. Delete from head. I'm gonna pass the head, and then I'm gonna traverse again. Okay. We got an error. Where's that? Oh, there's an error here. Should be head P, not head. Mhm. Oh, this is an issue actually. And we go to, yeah, it's a small silly mistake. Okay, over here, I call the delete from head function and then I traverse again. Let's see. Okay, so I created this linked list. I added to head, added to tail, and then added to position. So this is the function we have. So this is the linked list we have. Then I call delete from head. And what delete from head does is that deletes the first value. So that means we are going to start from 89. So 89, 45, 500. And after the first one. So yeah, let's remove this first traverse one. Otherwise, it's a little bit confusing. So over here, we construct the linked list. Then we traverse to see how linked list looks. Then I'm calling this delete from head. Then we take a look at how it looks again to see whether the delete from function executed the way we wanted it to. So right now, after constructing, we have this linked list. We remove the first one. So now 334 is gone. So it's starting from 89. So yeah, add to head. So delete from head works like that. Okay, so we are done with that as well. Then what we had to do is delete from tail. Okay, let's go through this quickly. Uh, delete from head, head, and then delete from tail. Then again, I'm gonna pass the uh, memory address of head pointer. All right. Give me a minute. Okay. Let's get back to it. Again, we check whether the linked list is empty. If so, then there's nothing for us to delete actually. Then what we're going to do is that uh, we are going to go to the node that's before the last node. So in the add to tail function, as you guys might remember, what I did was I uh, started from head and came to the last one, and then I updated the value of the last one and included this node as the last node, this new node. Uh, Sorry. When we are deleting, we should be we should go to the node that comes before the last node. So that's how you can remove it. You can't be in the last node and remove the last node itself. That's not going to work. You should be before the last node and then cut this off. Like you can't just stand in a branch that you are trying to cut from a tree and then remove the branch. You are also going to fall down. So basically your program is going to crash. So what you should be doing is that you should stand before the area that you are going to cut down in a tree. Okay, I'm using a metaphor here, just don't confuse yourself. Okay, so the same way, you should be in this node instead of the last one. So this is the last node. Let's remove this one. So let's remove this. So this is the last node. So I can say it's the last node. I need to go to this one. So one thing about this is that we could easily recognize the last node because the next value of last node was null. All right, it's very easy to recognize that. But how do we recognize the node that's before the last node? It's also the same technique, but a little bit different. So the thing is, okay, these are structure pointers. So in structure pointers, you can use the arrow to access its values. All right. So if we take a look at temp in our code, okay, here, so temp is actually the data type. If we check the data type of the temp, go a little bit up. So over here, we declare it as a pointer to a structure data type.
So because of that, we can access the members of that structure using this arrow notation. Because temp is a structure pointer. The same way, next is also a structure pointer. So if you go to the declaration, so over here, the structure, as you can see, next is also a structure pointer. That means uh, by using then by using next, we can access the values of the next node. So let's say that we are in this node. So we are in this node. Let's call it temp. And we can temp is a pointer that holds the memory address of this node. So we can access its values using the arrow notation like this temp data, or even you can say temp next. Okay, the same thing. Let's erase this. So let's write this one again. Okay, so what I'm going to have is this temp variable. Temp is going to hold the uh, memory address of this. Let's say that it holds the memory address of this node. So that means I can access its values. Temp data temp next. So same, I can access its values using this arrow notation. Temp is a pointer pointing to this node. If you take a look at temp next is also a pointer that's pointing to this memory space. So technically speaking, we can access its values. Technically, you can actually access them. So temp next, this is a pointer pointing to this node. We can access its values using the arrow notation. Right? Temp next is a pointer. So we can also say temp next arrow next. All right. So that way, so the significant thing about this node, the node that's before the last node, is that temp next should be null. Hopefully that's clear. Okay. Temp next is pointer. So point into the memory space of a node. So by that, because of that, we can use temp next to get the value of this. If temp next is null, that means we are in the node that's before the last node. So that's what we're going to do in this delete from tail function. So I'm gonna create a temp struct digit. Yeah, struct. So it should be struct or temp or temp equals memory address of head. So the condition is temp next is not equal to null. If it's equal to null, that means I have arrived to my destination. I'm not going to go through this one again because I covered it in the previous one. Okay. So now what I'm going to do is I'm going to free uh, temp next. which temp is after executing this function, sorry, for loop, this for loop temp will be at or before last node. All right. So I free the last node because temp next is the last node. Then what I'm going to do is temp next. I set temp next to be none. That's it. Let's compile and see whether do we have any errors. Oops. We don't have any errors. Let's uh execute this and see how it's gonna go. Okay. Okay. Let's call compile. No issues. Okay, we have an issue. So compile error somewhere. Sorry, runtime error somewhere. Delete from tail. What would that be? Temp temp is equal to memory address of it. So what's the issue here? What's the boundaries? Not pasting it. Why is that? Let's comment this one out. Let's try to print the value. So I'm going to print the data that's stored in the uh, temp node. So in the temp variable. Okay, it returned 100. So that means I'm in the correct temp. So temp data, it's so here it prints 100. That means I am in the right memory space. Okay. So the problem is with this one. It doesn't let me free this with the last node. Uh, why am I getting that error free temp next? Is that? For some reason, I'm getting an issue. I'm trying to free that. Why is it? Uh, yeah. Yeah. I will. Give me a moment. I'll find out what's wrong.